Welcome guys. We're going to talk about the convergence of Fourier series, and I really did not want to make this video, but after solving this very problem I was like, okay, well, I have to actually say what this is and how it applies to what I did when I said let s equal to 0. So the thing is this: when we pick a particular value in our function, we try our best to see if that value of x would converge at the function itself or the average value of the function. When I said let s equal to 0 here, do you know or agree that this function is a discontinuity at 0? See, there's a discontinuity because if you graph this function, there was no point where x was equal to 0. X was never equal to 0. S was what? Discontinuous at 0. So there's no f of 0 value. There's no f at 0 because at 0 there was a discontinuity. Now how do we then get f of 0? To get f of 0, we take the average value of the discontinuity. Here's the thing. So we kind of know, or we kind of agree that, okay, at s equal to 0, but s was never equal to 0. S was never equal to 0. Now look at this. Look at this. If our function, for example, if our function f of x was equal to x at, let's say, minus pi less than x less than pi, for example, and we're asked to find f of 0 or f at 0. Now, f0 would definitely become the function, would just be when you impute this x into the function. So that's just 0. Or let's say f of, let's say 2. It would just be equal to 2. Or even if this was s squared, for example, and we're asked to find f of 2, we're going to use the function itself to get our 2 squared, so that's 4. So we're able to get our function value because with this interval, our Fourier series would be having its value here converging at the function itself because there was no discontinuity at s equal to 2. There was no discontinuity at s equal to 2. Remember that pi is bigger than what? 2. Pi is 3 point something. So there was an x value all through the way until it got to pi. So this is the meaning of it is convergent at the function itself. At the function itself. But if you take a look at this, this very one, there was no x equal to 0. So here's what we do. We're going to say that if we're looking for f of x, whenever there's a discontinuity at that x point or at that value of x, what we do is to take the function at s plus, so the right hand, add it up to f of x minus the left hand limit and divide it by 2. So it's like taking the average of our discontinuity. That's what we're going to do. So in this case, since we're looking for f of 0, this will be f at 0 plus. Any of them can come first. It's an average. So f of x 0 minus squared. So what I'm trying to say is, at this point, you get what the value of this would be. So this will be the 0 minus, because this is the other part. So this will be the negative side, while this will be the positive of it. You know, if you kind of graph this function, I do have space. Okay, let me use this place. If you kind of graph this function, so this is 0, this is pi, and this is minus pi. So from minus pi to 0, it was at 0 all through. So it was flat at this point. Then from 0 to pi, it was s squared. So it became a parabola at that point. So this is what our function looks like. So when they say 0, but please take note, there's a discontinuity here. So if you actually want to plot this, the straight line part would have a 0 here, and then the next 0, at the same point again, will be going up. So there's a discontinuity here. Now, the 0 minus is the value at this place, this location, 0 minus, and here, 0 plus. So right now, 0 minus, or let me start from the 0 plus, this is where the 0 plus would be. So if you say 0 squared is 0. Plus, when you say 0 minus, here, this is still 0. So 0 plus 0 over 2, that's 0. So f naught is just 0. So I was supposed to show you this before saying let s equal to 0 and putting, especially when I replace f of 0 with 0. Yeah, especially doing this, when I replace f of 0 with this, I ought to actually say that, oh, f of 0 becoming 0 was because at f of 0, when you take the average limit at the discontinuity, because there was no s equal to 0 here, no s equal to 0. So when you pick your average value of the discontinuity, your answer will be 0. That is why. Now also take note that this cannot only happen when s equal to 0. Let's come back to this very function. Let's come back to this very function, f of s equal x squared minus pi less than x less than pi. Now what if we say, okay, let s equal to 0. Let x, or at s equal to 0, let me put it at s equal to, I've used 0 already, at s equal to pi. Now if we say s should be pi, there's no s equal to pi. It's discontinuous at this very point. It's discontinuous at this very what? At this very point. So same thing would then apply here. Same thing would then apply at this very point. So we're going to have f pi plus, oh, that's a, plus, and f pi minus over 2. So that's basically what it is. So this is what the convergence of Fourier series does. It investigates if at a particular value the function would converge to itself or to the average value of discontinuity. That is what it does. So you have to be very, very careful. So this will be all for this very video. I just wanted to use it to explain this so you understand why f of 0 became 0. So it's very important. I'll see you guys in another video. Bye.